AP Calculus BC, Unit 5, Day 8, office hours. So here are the even answers. I posted them online also, so hopefully you've checked them. But if not, pause the video real quick and check them. And the two odds are in the back of the book, so you should check those in the back of the book. Okay, let's try these out. Let's do these problems. So these are improper integrals involving infinity in their limits. So starting with 6. 6 is 1 to infinity of 2 over x cubed dx. You don't need to sketch these, but you should say, okay, you know what? X equals 0 is in a vertical asymptote. So this is just setting it up for our next lesson. But in this time it's okay. It's not between the limits. So we're going to rewrite this as a limit as b goes to infinity of 1 to b. And I'm going to rewrite it as 2x to the negative third. It's a power rule. And so that's going to be the limit as b goes to infinity of 2x to the negative 2 divided by negative 2, 1 to b. Which might rewrite in a little nicer form, negative 1 over x squared. And then we're going to plug the limits in. So it's going to be negative 1 over b squared minus negative 1 over 1 squared plus. This is going to go to 0 when you apply the limit, and the answer is 1. It converges. So that's number 6. Number 8 is the integral of 1 to infinity of dx over the 4th root of x. So x cannot be 0, but it's okay this time. It's not between limits. I'm going to rewrite it as a limit as b goes to infinity of the integral. I'm going to rewrite this as x to the negative 1/4. It's a power rule. And that's going to equal the limit as b goes to infinity of the antiderivative is going to be x to the 3/4 divided by the new exponent multiplied by the reciprocal. So that's going to be the limit. Let's see. Limit as b goes to infinity of, I'm going to plug limits in, 4/3 b to the 3/4 minus 4/3. 1 to the 3/4 is going to be 1. Now, if you plug infinity in here, it is going to go to positive infinity. Now, that is technically not the answer. The technical answer is diverges. But I do want you to write positive negative infinity. All right, number 10. Number 10 is negative infinity to 0 of dx over x minus 2 cubed. So x cannot be 2, which is okay for us because we're integrating from negative infinity to 0. But that will be an issue very soon. So we rewrite as a limit as b goes to infinity of b to 0. And I'm going to read this as x minus 2 to the negative 3rd power. This is a power rule problem. So So we can get the limit as b goes to infinity of, the antiderivative is going to be x minus 2 to the negative 2 divided by negative 2. And it might be helpful to rewrite this a little nicer. It's going to be negative 1 over 2 x minus 2 squared. So now we're going to plug the limits in, upper and lower limits. So it's going to be negative 1 over 2 x minus 0 squared. Sorry. So if we plug 0 in, we get negative 2 squared, right? Minus negative 1 over 2b minus 2 squared. Now, this is going to be, when b goes to infinity, the bottom's going to blow up, it's going to go to 0. And you're going to be left with this term, which is going to be negative 1 over 8. Negative 1/8. So it converges to negative 1/8. All right. 12. So integral 2 to infinity of 3 dx over x squared minus 1. Now, of course, we're going to rewrite as a limit, but we have another issue that we're going to have to take care of pretty quickly, and this is this is not inverse tangent. If it was plus, it'd be inverse tangent, so we're going to have to do partial fractions. So I guess we could go to figure that out. Multiply 3 by the least common denominator. 3 equals a x minus 1 plus b x plus 1. Plug a negative 1 in. Get a equals, so it's going to be 3, negative 2, negative 3 halves. Plug positive 1 in. You get b equals positive 3 halves. So those are partial fractions. By the way, x cannot equal negative 1 or positive 1. Those are vertical asymptotes, which are okay for us because they are outside of our limits. So we're going to rewrite this as the limit as b goes to infinity of 2 to b. And I mean, we could, we could put these in here. Let's see. Did I make a mistake? Oh, I wrote the problem down wrong. This is an x. Well, I'm going to have to go back and fix it. And this would be an x. And so one of them is going to be over x, and one's going to be over x minus 1. So you multiply through. That should just be an x. And so if I could plug in 0 and get a equals negative 3. And if you plug in a 1, you get b equals positive 3. So, little mistake there. All right, so this is going to be negative 3 over x plus 3 over x minus 1. And the antiderivative is going to be negative 3 natural log of the absolute value of x plus 3 natural log of the absolute value of x minus 1. And we can make this nicer, which might be nice. Combine these, use log rules. So we could just leave a 3 in front, because they both have that same coefficient, natural log of x minus 1 over x. And then we're going to plug the limits in, the upper and lower limits. So 3 natural log of b minus 1 over b minus 3 natural log of, plug 2 and you get 1/2. So if we plug infinity in here, it's going to be infinity over infinity, right? So technically, we would use L'Hopital's rule, but we could do dominant terms too. These are the dominant terms. So the inside of this is going to go to 1. And natural log of 1 is 0. So the answer is -3 natural log of 1/2. It converges. Now, there are some other answers we could have brought this 3 in earlier. You could bring it in now. It's negative, so it's the same thing as natural log of 1/2 to the -3, which is the same thing as natural log of 8. Right? That's another possible answer. So converges. I mean, that's a nice answer. Probably be like that on multiple choice. 14. -infinity to 0 of 2 dx over x squared minus 4x plus 3. So we're going to have to do partial fractions here, it looks like. X minus 3, x minus 1. So it's going to be a over x minus 3, b over x minus 1, or the other way around. It's up to you. Multiply through by the least common denominator. 2 equals a x minus 1 plus b x minus 3. So plug 3 in everywhere. And that would give you a equals 1. 2a equals 2a. 2 equals 2a. We could plug a 1 in, and that's going to give you b equals -1. Doing a little work in my head there. So we're going to rewrite it as a limit as b goes to infinity, b to 0. And it's going to be 1 over x minus 3 minus 1 over x minus 1. So the antiderivative is natural log of absolute value of x minus 3 minus natural log of the absolute value of x minus 1. We could combine this together. That should be -infinity. Natural log of the absolute value of x minus 3 over x minus 1. So we're going to plug limits in. And plug 0 in, you're going to get log of 3 minus natural log of the absolute value of b minus 3 over b minus 1. So if you plug infinity in, it's going to be infinity over infinity. These dominant terms, it's going to go to 1. Natural log of 1 goes to 0. So the answer is going to be natural log of 3. So it converges. All right, 16. Is -2 to -infinity. Seems kind of backwards, which is fine. They can be backwards. So again, partial fractions. Multiply through by the least common denominator. Plug a 0 in. A equals -1. B equals +1. Limit as b goes to infinity, -infinity. Let's see. Okay. So it's going to be -2 to b And it's going to be negative 1 over x plus 1 over x minus 2 dx. So we're going to get limit as b goes to negative infinity. Antiderivative is going to be negative natural log the absolute value of x plus natural log the absolute value of x minus 2. We could combine these together. It's easier to do it now than later. This is going to be natural log of x minus 2 over x. So we're going to plug b in. And we plug negative 2 in. So negative 4 over negative 2. So it's going to be natural log of 2. Now, if we go to infinity, this is going to be infinity over infinity. Those are dominant terms, so it's going to go to 1. And natural log of 1, even though they're both negative, because they're absolute values, that's going to go to 0. So the answer is going to be negative natural log of 2. Or natural log of 1/2, if you want to bring the negative 1 in front, or natural log of 0.5. So there you go, 16. I'll do 17, 23 at the end. I'm going to just do I'll just do it now. Okay. 17. So 17 is 1 to infinity of x e to the negative 2x. Now we can't integrate that, so we're going to have to use integration by parts, limit. And I kind of forgot on this one, say x cannot equal 0 or 2, which is okay for us. Previous problem, x cannot equal 1 or 3, but that's okay with us today. All right, so limit, we have poly and we have expo. Poly expo. Now the good thing about this is you can use a shortcut, poly expo or poly trig. So you can start with positive. You can take derivative x is 1, derivative 1 is 0. Plus negative. This one you can integrate, so it's going to be e to the negative 2x, but negative 2 is going to pop out, so it's going to be negative 1/2. It's going to be e to the negative 2x, but it's going to be positive 1/4. And then we multiply through by a diagonal. And so what we get is we get the limit as b goes to infinity of 1 to b. Actually, we've already done the integration. And this is the antiderivative, so it's going to be negative 1/2. We can even write this. Let's see, negative 1/2 x e to the negative 2x minus 1/4 e to the negative 2x. So far, so good. Now, I would probably, I'm going to rewrite it. I'm going to plug limits in, but I'm going to write them as, I'm going to write the negative exponents as positive exponents. So this is going to be negative b over 2e to the negative 2b minus, I got to put b in here too, 1 over 4 e to the negative 2b. And then you got to subtract, you got to plug 1, it's going to be negative 1/2 e to the negative 2 minus 1 over 4 e to the negative 2. All right, what happens when we plug infinity in? These guys, and I rewrote the negative exponents as positive, so it should not be negative anymore. Now what happens if b goes to infinity? You get infinity over infinity, but the bottom term is dominating the top. That's going to go to 0. That's going to go to 0. your answer is just going to be 1 over 2e squared plus 1 over 4e squared. And I think we could probably write that answer a little more compactly. Least common denominator, that's 3 over 4e squared. Or you could rewrite it back as a negative exponent, I guess. But it converges. So that's 17. Let's see, 18. 18. We're doing negative infinity to 0 of x squared e to the x dx. Can we integrate that? No. I mean, we could rewrite it limit as b goes to negative infinity of b to 0 x squared e to the x dx. But we're going to need to do integration by parts, limit. And we have poly expo shortcut. So this one's going to be 2x, 2, 0. E to the x, e to the x, e to the x. Plus, minus, diagonals. It's way faster than doing it repeatedly by hand. Okay, so we're going to get limit as b goes to negative infinity of x squared e to the x minus 2x e to the x plus 2 e to the x. And it's going to be b to 0. So we're going to plug 0 in. So 0 squared e to the 0. It's going to go away. Minus 2 times 0 e to the 0. It's going to go away. Plus 2 e to the 0. That's not going to go away. That's going to be a 1. Minus, now we're going to plug in a negative. B squared e to the b minus 2b e to the b plus 2 e to the b. So we're going to have a 2 left here. When we plug infinity in, it's going to be negative infinity squared over e to the infinity, right? And minus, this is going to be negative infinity on the top over e to the infinity plus 2 over e to the infinity. And that's all getting subtracted. So it's going to be infinity over infinity, but the bottom term is dominant. So these are all going to 0. So your final answer is 2. It converges. So you're getting a lot of good practice with other stuff in this chapter. 20 is 0 to infinity of x plus 1 e to the negative infinity. So of course we're going to rewrite it as a limit, but this is integration by parts also, limit. With poly, the whole thing's poly expo, shortcut. So we're going to repeatedly take the derivative of this one. So 1 and 0, positive, negative, positive. This is going to be e to the negative x, negative, and this is going to be e to the negative x. Multiply through by a diagonal. And so we're going to get the limit as b goes to infinity of, and this is the antiderivative, so it's going to be negative x plus 1 over e to the x. I'm going to change the negative exponents right now. That's going to be negative minus 1 over e to the x. So if we plug b in, plug 0 in, that's going to be 0. 0 plus 1 is 1 over e to 0 is 1, so it's going to be 1, negative 1, minus 1. Now, when we plug infinity in, we get infinity over infinity, but this is a dominant term, so it's going to go to 0. That's going to go to 0. And what's going to be left is positive 2. Positive 2 converges. (22) So we integral from negative infinity to infinity, 2x e to the negative x squared dx. Always consider easier options. This is U-substitution. U equals negative x squared du equals negative 2x dx. I would like the 2x dx. I don't want the negative though. So this is going to be limit as b goes to infinity of negative b to b. We're going to need negative in front for this. It's going to be e to the u du. So the antiderivative is going to be e to the u plus c, negative. So it's going to be limit as b goes to infinity. Now we need to replace it with e to the negative x squared. Right? Now if we plug b in, it's going to be negative 1 over e to the b squared minus negative 1 over e. Now, if we plug negative b in, it's getting squared, right? So it's going to be positive b squared, but then there's an extra negative, so it is going to end up in the denominator still. And so plus plus, I mean, guess what? These guys just cancel each other out and get 0. But they would go to 0 anyways also. So the answer is just going to be 0, even before you take a limit. It would be 0. But these would each end up being 0 also. So however you do it, it converges to 0. All right, a couple more. Got 23. Negative infinity to positive infinity of dx over e to the x plus e to the negative x. Now we could, we could try some different techniques. I think, we could try and clean it up first. Think of it as e to the x plus 1 over e to the x. And then you can multiply the top and bottom by e to the x and get rid of the partial fractions. So then that would be e to the x dx over e to the 2x plus 1. Now, would that work? You could try, you might think, well, let's try U-substitution at e to the 2x plus 1. and then du would be 2e to the 2x dx. Well, that doesn't work. That's not going to work because you just need e to the x dx. So that's not going to work. Well, what if it was inverse tangent, right? You put e to the x in here, so u would equal e to the x, and du would equal e to the x dx. Oh, that works. It's going to be inverse tangent, right? So equals limit as b goes to infinity of negative b to b, and then it's going to be du over u squared plus 1. So it's going to be inverse tangent of u. But then you got to change it back to x. So it's going to be inverse tangent of e to the x. So it's going to be e to the b minus e to the negative b. Now, if you plug infinity in, this isn't going to infinity. But what happens to inverse tangent is going to infinity? If you plug infinity in here, it's going to go to 0. So what's inverse tangent of 0? Now, I find it helpful to just draw a quick sketch of graph for these. So tangent, and I don't know if you guys have the inverse tangent graph memorized. I generally don't, but I do know that tangent equals sine over cosine, right? So whenever sine is 0, you get an x-intercept because tangent is going to be 0. Whenever cosine is 0, you can get vertical asymptote. So a quick sketch, tangent curve repeats itself, right? And then the inverse function is going to get flipped across y equals x. Everything that's x becomes y. So the inverse tangent graph has a horizontal asymptote at y equals pi over 2 and negative pi over 2. And this is principal values because the inverse tangent graph is actually, inverse tangent function's there. And then it would look like this. So as you go to infinity, it's going to pi over 2. As you go to 0, it's going to 0. So the final answer is pi over 2. It converges. It's pi over 2. Kind of crazy. All right. Last one, 24. Okay, 24 is negative infinity to infinity of e to the 2x dx. This one's actually nice to integrate, not terrible. Limit as b goes to infinity of negative b to b. You could do U-Substitution on this, but I feel like it's pretty unnecessary. The answer to is going to be e to the 2x. X 2 is going to spit out, so divided by 2. It's going to be e to the 2b over 2 minus e to the negative 2b over 2. As b goes to infinity, this term blows up, right? Blows up. This term, it's the same as 1 over 2e to the infinity like that. This is going to go to 0. But the whole graph for sure blows up. It goes to positive infinity. It diverges is the technical answer. Diverges. So there you go. Some good practice on the new stuff. Also, some good practice on some of the other recent strategies we talked